Hey guys, let's talk about graphing inequalities. So we're going to graph basic inequalities, which pretty basic, few steps along the way. But before we get there, we need to kind of talk about what does a graph of inequality represent? How do we do it? So what the graph of an inequality represents is we're eventually going to solve pretty complex inequalities. We're going to get down to answers like this. When we graph them, everywhere that is shaded and represented in our graph is all the solution set for this inequality. So basically we're graphing the entire solution set and graphing all the solutions to this problem. Now there's a few things you're going to have to understand. Since we are dealing with inequalities, the inequalities drive a lot of what's going on with how to graph these. If we have a less than or a greater than, what we're going to use, and I'll show you through example, we're going to be using some open circles in our graphing. Where if we have a less than or equal to or a greater than or equal to, we're going to be using filled in or shaded in circles like that. So less than or greater than, not equal to, open circle. If we have the equal to included, then filled in circle. Okay. So we're going to use this, and then we're going to have to do some testing to figure out which way this is going to be shaded. So our first example, I have x is less than or equal to 7. So here's what I do is I look for, we have a basic, we have our variable, we have our number, we have our inequality. First thing I start off with is I go to where is our number at on the number line. So 7 is all the way down here. So then looking at the inequality, I have to judge, do I have to have an open or a closed circle at 7? What we're going to have in this one is we're going to have a closed circle. What that means, when you have a closed-in circle like that means 7 is included in this solution set. So if I plug in 7, it will give me a true inequality. If I would have had an open circle at 7, that means we include every single number up to an approach or approaching 7, but not 7 exactly. So 6.9999999, something like that might be a solution there, but 7 exactly, if you have an open circle, would not be part of our solution set. So, got my filled in circle, got it at 7, we're good to go here. The only thing I have to figure out is which way do I shade? Do I want all these numbers to the left, or do I want all these numbers to the right? So what we're going to have to do is we're going to have to test the inequality. We're going to test and see, is one of the numbers on the left a solution, or is one of the numbers on the right a solution? You can really pick one side or the other. It doesn't matter. I'm going to pick the left side. So we're going to test the left. Okay? We're going to test the left side to see if our solutions are all to the left or are they all to the right. Because it's got to be one way or the other. It's not going to be both. So test the left. So I need to pick any of these numbers over here. I could pick x equals 3, 2, 1, 0, negative 1, negative 2. I need to pick one of these numbers to the left and plug it into my inequality. Now, it doesn't really matter which one you pick. I personally like to pick x equals 0 because it's the easiest number to work with here. So we're going to test the left, which we're going to test x equals 0. So I'm going to plug in 0 into this inequality. So I have this inequality statement here. Now, if the statement is true and I tested the left side, I'm going to shade on the left side. Because that means not only is 0 a solution, but all these other numbers on the left sides are solutions. If I tested a number on the right side like 10, and I found out 10 is a solution, then all the other numbers on the right side are solutions, so I'd shade to the right. If I plug in a number to test whether the left side is a solution, and it's not, then by process of elimination, it's one or the other, right? So if the left side's not where the solutions are at, then it must be the right side, and vice versa. If I test the right side, and it's not one of my solutions, then by process of elimination, that means it's got to be on the left side. So I have 0 is less than or equal to 7. So I got to ask myself, is 0 less than or equal to 7? Yes, it is. That is a true inequality. Another way you can think of it is the inequality should open to the larger of the two numbers. So if you look at 0 and 7, the larger number is 7. We're opening towards that. So I know x equals 0 is a solution. So since the left side, this 0 is a solution, all these other numbers are solutions over here. So what I'm going to do is I'm going to shade to the left. And how I do that is I kind of darken in a line covering all those numbers on the left side all the way up to the arrow, and boom. What this means is if you pick any number over here and plug it into this inequality, it's going to work out and be true and be a solution. So if you plug in -6, -10, -1, they're all solutions. So going a little bit quicker on this second one. X is greater than -3. So what I like to do is I find where my number at is on the number line. We're right here, -3. Because of the inequality then, I have X is greater than -3. I'm not greater than or equal to, just greater than. I'm going to have an open circle at -3. So I'm going to have an open circle at -3. So now I got to figure out, are my solutions to the left or are my solutions to the right? So you can test one side. I'm going to try this left side. I wonder if -6 is part of my solutions. If it's true, then all these numbers to the left are the solutions. So I'm going to test the left. And let's do x equals -6. So we get something a little bit different here. X equals -6. So if I plug in -6 into the inequality, replace x with -6, I have -6, the inequality, and -3. So I got to ask myself, is -6 greater than -3? Well, it's not. That is false. The bigger number there is -3 is much bigger than -6, so it's false. So I tried to the left, and we failed. If it was true, I would have shaded to the left. By process of elimination, if I know this -6 on the left isn't a solution, then I know a number on the right is a solution. So I could go ahead and assume it's a solution on the right. If I wanted to, I can also check, maybe x equals 0. So if I plug in 0, yep, that is a solution. 0 is greater than -3. It works. So I know I'm going to shade everywhere on the right with an arrow. Okay. Now what this means is if I plug in any of these numbers over here into this inequality, it will work out true. The only number that doesn't work is -3. The reason being is it's not also equal to. -3 is not greater than -3. So that's why we have the open circle. Last example I'm going to show you. 0 is less than or equal to x. So my number is 0 right in the center, and because of the inequality, because we're less than or equal to, I need a filled in circle at 0. So I got to figure out, is my solutions to the left or to the right? So you can pick one way or the other, it doesn't matter. I'm going to let's test the right this time. And you can pick any number over here. Let's do just 5. I'm going to test the right, x equals 5. So if I get a true statement, we're going to shade to the right. If I get a false statement, I'm going to go to the left. So we're going to plug in 5, 0 less than or equal to 5. Ask yourself, is this true? Is 0 less than or equal to 5? Yes, it is. So it is true, which means I'm shading everything to the right. So what this means is all these numbers over here that are shaded in are all solutions to this problem, including 0 because it's a filled-in circle. And that was graphing inequalities.